Hello everyone, I am Jill. Today we will be showing you our project EMG controlled wheelchair. An EMG signal is a body signal which is generated by a neuromuscular system. A muscle contracts whenever it receives an impulse from the nervous system. The impulse is in the form of an electric potential emitted from the dendrite of one neuron to the axon of another. And when this happens, the neuron is said to be fired. When multiple neurons fire, the electrical potentials add up to a larger signal called the EMG signal. An EMG signal can be differentiated as a function of frequency, phase, or amplitude and can be used for control purposes such as a wheelchair in our case.
I am Ritik Shah. I will be continue with the first subsystem of our project. So the first step is to acquire and condition the EMG signal. To acquire the signal, we use surface EMG electrode. This signal is very weak, hence we have to amplify it to a higher value. An example of an amplified signal is shown in the following video. So you can see in the video an EMG signal, raw EMG signal. After amplification, we filter the signal using an high pass filter and a low pass filter to block all the noise. The signal with frequency below 20 Hz or above 500 Hz are considered to be noise, so we filter them out. We rectify the signal to get only the positive pulses and integrate it to get a smooth analog wave. We use an inverter to invert the polarity of the signal and apply some gain to attain desired amplitude. To amplify, we use a precision gain amplifier INA 106 and TL0881 operational amplifier base circuit for the rest of the stages. Finally, we get an analog signal at the output whose amplitude increases as the time for which the muscle is contracted increases, and this signal is provided to the microcontroller to control the wheelchair.
So for controlling, we use a Raspberry Pi Pico microcontroller. The output of the previous subsystem is an analog signal as shown in the diagram. It is provided to the ADC input of the Raspberry Pi Pico. The Pi Pico provides a 16-bit microcontroller, so the analog signal is converted into digital form, which has around 65,536 steps, and which gives a very precise value, a very small value of the step size. So the conversion is very precise. Now, thresholds are set according to which the Raspberry Pi Pico will produce an output at the which is given to the DC motors, and the DC motors are connected to the axle of the wheelchair. Hence, it will move. Now, the Pi Pico, it cannot drive two DC motors. Uh, hence we use a motor driver module, which isolates the DC motors from the controller, and it just takes the controlling output from the controller and gives it to the motor. Now the Pico has been coded in such a way that it will give an output only when the peak is reached. So this is done in order to prevent any accidental motions. So for example, if the threshold for left turn is around here at 2.5 volts, so the operator will have to give 2.5 volts, and the value will increase from 0 till 2.5. In the path, when it is increasing, it will cross the threshold for multiples. Let's say cross the threshold for forward. So for the whole range, the output at the uh, wheelchair will be forward motion. So that is avoided if we give an output only when the peak is reached. Now, as a safety feature, we've also added a speed control using a potentiometer, where the speed can be controlled by changing the position of the wiper of the potentiometer. This can come in handy in emergency situations, like if the operator needs to apply a sudden brake, he can just uh, put the wiper at its lowest position, and the wheelchair will stop moving.
So, to sum up, we have designed a system that uses an EMG signal to control a wheelchair, which can be extremely helpful for to people who are not able to walk. Since we have designed it as a two-part system, we can use either of these systems for different individual purpose. Thank you.